Okay, to probably -5 people that are going to watch this. All right, so I'm going to do a couple of problems here just to go over a few things. And we want to find the nth term of this quadratic sequence, right? So the first thing we have to do is find the first difference. That's 7. That's 9. Looks like this is going to be 11. And that's 13. Well, it tells me that's not linear. And if I take the second difference, I get 2, 2, 2. So now I know that this is a quadratic sequence. So I know it's a sequence that goes like this. Quadratic sequence, and if I have 2, I get 1. And it's going to be a 1n square sequence, but I don't need to really write down 1 there. So an n square sequence, imagine if you substitute 1 right here, you got 1 squared, 2 squared, 3 squared, 4 squared. So this is a n square sequence. So that would be 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. So what we need to do is we need to subtract the original sequence and our n square sequence. So I'm going to take that quadratic sequence out of this, the first number there. If I subtract, I get 2 minus 1 is 1, 9 minus 4 is 5, 18 minus 9 is 9, 29 minus 16 is 13, and 42 minus 25 is 15. No? 17. Right? So now you notice that you get another sequence. Okay. Sometimes actually you might even stop here, but in this case you have another sequence here, and if you want to find out what kind of sequence you have a 4, 4. If you take the first difference, it's 4. So you have a linear sequence. So it's a quadratic sequence and a linear sequence together. So I know so far that this set of numbers is made up of this sequence. Now, you know the difference is it goes up by 4, by 4, by 4, by 4, by 4. So this tells you it's a 4n sequence. Right, so imagine what a 4n sequence is. 4n sequence is if n equals 1, it would be 4 times 1. If n equals 2, it would be 4 times 2, 4 times 3, 4 times 4. So n sequence would be 4 would be the first term, and if 2 is the second term, it would be 8, and then it would be 12, it would be 16. And hopefully you're noticing it's the 4 times table, right? Because you're going by 4. So, and 4n sequence, and in the 4n sequence, the first term of a 4n sequence, obviously, would be 4. Second term would be 8. The third term is 12. Fourth term is 16. And the fifth term is 20. So I know it's an n squared sequence plus a 4n. Now, if we were to do the 4n, you notice that a 4n sequence is 4, 8, 12, 16, 20. But obviously, doing a 4n sequence is not getting me the 1, the 5, the 9, the 13, the 17. It does go by 4. This also goes by 4. So, but to adjust my 4n sequence so I do get 1, I do get 5, and I do get 12, and I do get 13, and I do get 17. What do I have to do to the 4 so that it becomes 1? What do I have to do to the 8 so that it becomes 5? So it'd be minus 3. So it is a 4n sequence. It's a 4 sequence here going by 4s, but subtracting 3. So just to check, let's make n equals 1. If n equals 1, that'd be 1 squared plus 4 times 1 minus 3. 1 squared is 1. 4 times 1 is 5 minus 3. And then 1 plus 5 is 6 minus 3. And that's 2. And there's something I did wrong. Hang on. 1 squared is 1. 4 times 1 is 4 times 1 is 5. 4 times 1 is 4. Sorry. So that's 1 plus 4 minus 3. And 5 minus 3 equals 2. And that's exactly my first term. So if I do it again, and I take my second term. So to get my second number, I would do 2 squared plus 4 times 2 minus 3. 2 squared is 4. 4 times 2 is 8 minus 3. 4 plus 8 is 12, and minus 3 equals 9. And that's my second term. So this I can use to find any term I want in this particular sequence. Okay. Do another one. So 5 to 11 is plus 6. 11 to 19 is plus 8. This looks like it's a plus 10. And I'm going to add one number. So to the other one, that would have been a plus 12. So that would give me a 41. So I'm just going to add one number because the more information I have, it's always the better. So again, I can tell this is not a linear sequence. Otherwise, everything would have been the same. So I take the second difference. I get that this is 2, 2, 2. And for this one, I know that it's a quadratic sequence again, an n square sequence. And if I divide 2 by 2, I get 1. So my coefficient here would have been 1. I don't need to write that. So far I know that this sequence is made up of n squared. And let's see what an n squared sequence is. And we did it like we did in the previous problem. N squared, 1 squared would be 1. 2 squared would be 4. 3 squared would be 9. 16, 25, and so forth. So let's remove the quadratic sequence out of this sequence here. So 5 minus 1 is 4. 11 minus 4 is 7. 19 minus 9 is 10. 29 minus 16 is 13. And this hopefully is 16. So again, if they were all the same, we would have stopped and would have been n squared plus whatever is here. But if there is another sequence in here, and this is a linear sequence, and then the reason I know it's linear because if I take the first difference, it's all going plus 3. So it's a 3n sequence, and a sequence that goes by 3. So a 3n sequence, right? So it's literally the 3 times table, right? 3 times 1 give me 3, 6, 9, 12, 15. So it's n squared plus a 3n sequence, but I might have to make some adjustments to the sequence. So a 3n sequence goes 3, 6, 9, 12, 15, but I don't really want a 3. I really want a 4. I don't really want a 6. I do want a 7. I don't really want a 9. I want a 10, etc. So if I did a 3n sequence, how do I adjust the 3n sequence so that I do get the 4, the 7, the 10, the 13, the 16? I would do the 3n sequence, and hopefully you can see that you have to go plus 1, plus 1, plus 1. So you get plus 1. Check. Substitute in. So you get 1 squared plus 3 times 1 plus 1. 1 squared is 1. 3 times 1 is 3 plus 1. And that gets me 5, which is this number right here. Let's pick n equals 2. So let's substitute over here. So n equals 2 would be 2 squared plus 3 times 2 plus 1. N squared is 4. 3 times 2 is 6 plus 1. 4 plus 6 is 10 plus 1 is 11. So you can tell I got my second term. So this is the sequence that I want, the nth term. Okay, so for any value, I can just substitute there and find the value of that particular term. Okay, so that's that. What's next? Oh, your favorite. So first thing we have to do is simplify, right? So I put a few 5 of these because they all represent something different. Now the first thing I'm going to do here is divide this side by 3 and divide this side by 3 before I do anything else. Cross cross, and I have left over 4x minus 1 less or equal to 3. Now I want you to stop here and just think for a second what this means. So ignore what's in here. Okay, I might even just hide that. So I don't want you to focus on what's inside. Oops. Well, pretend. So don't focus on what's inside, but focus on the absolute value. Think of all the numbers that you can take the absolute value so that it's less than 3. So draw a number line. We're not solving anything. I just want you to understand. This says the absolute value of a number that I don't know of is less than 3. What could those numbers be? Well, if it's 4, absolute value of 4, is that less than 3? No. So 4 is not going to work. Absolute value of 3, is that less than 3? So that's already tells me that works. 3.1, absolute value of 3.1, is that less than 3? No, it's not. So obviously numbers here on this side, these numbers over here, will not be part of my solutions. But 3 does. If I take the absolute value of 3, it's 3, and 3 is definitely less or equal to 3. So 3 is part of my solution. If I take the absolute value of 2, and I put it over here, is the absolute value of 2 less than 3? Yes, so 2 works. 1 works, 0, and any number in between, 2.9, 1.6, all these numbers, if I take the absolute value, will be less than 3. So numbers here, all the way to 1, all the way to 0. How about from 0 to negative 1? 0.9 negative. If I take the absolute value of that, would that be less than 3? Yes, it will. Absolute value of negative 2, would that be less than 3? Yes, it will. Absolute value of negative 3, will that be less than 3 or equal to 3? Yes, it will. Now, what if you take the absolute value of negative 3.1? So think about that for a second. Take the absolute value of negative 3.1. That would be 3.1. And is 3.1 less or equal to 3? No, it's not. So I'm going to step on the brakes, and I can't. Numbers on this side will not work. So I know that any number in here, if I take the absolute value, makes that inequality true. So you know what the answer is already. Now, problem is, let me delete this. There we go. What can this x is? So how do I pick values for x so that when I do my calculation, 4 times a number, and then I subtract 1, whatever result that ends up being, it has to land between negative 3 and 3. So I'm looking for values. So if x equals 2, will that work? Well, 4 times 2 is 8. 8 minus 1 is 7, and 7 is definitely not less than 3. So when x equals 2 doesn't work. How about when x equals 3? Well, I don't want to guess. Okay, so one way of doing this is we can set up our inequality. So I know that whatever this is going to be has to be between negative 3 and 3. So this, when you see the less, it's an AND problem. So and you can remove the absolute value sign for a second and write 4x minus 1. So whatever this is going to be has to land between 3, and it has to be greater than negative 3. It has to be in between. Right? This value has to be between here. Right? So whatever we find x to be, when we substitute, has to turn into a number that's between negative 3 and 3. Well, now you solve it. Well, we're going to do plus 1 on both sides, on all 3 sides, sorry. This becomes negative 2, less or equal to 4x, less or equal to 4. Divide by 4, everybody divide by 4. If I divide by 4, I get negative a half on that side, less or equal to x, because and less or equal to 1. So the value of x that I can use to go back here to make that inequality be less than or equal to 3 are between negative 1, negative a half, and 1. So let me draw that number line. So you got a 1 over here, you got a 0, you got negative 1, and here it is negative a half. So if the x, and this is shaded, I'm pointing side. So x can be any number in here. So just to try it out, let me take that over to the side here. I got 4x, absolute value 4x minus 1 less or equal to 3. So let's pretend that I say that x equals 0. If I substitute, I get 4 times 0 minus 1, absolute value, less than 3. 4 times 0 is 0, and I'm left with negative 1, and the absolute value of negative 1 is 1. And that's less than 3. So 0 works. So if I pick 0. Want to pick something else? Let's pick something else. Let's pick x equals, I don't know, let's pick x equals, x equals 0.2, which is right here. Will this work? So again, 4 times, in place of x, I'm going to put 0.2 minus 1 less or equal to 3. 4 times 0.2, okay, it's going to be 0.8 minus 1 less or equal to 3. And what's 0.8 minus 1? It's negative 0.2, less or equal to 3. And what's the absolute value of this negative 0.2? It's 0.2. And is 0.2 less or equal to 3? Yes. So any of these values, okay, that I pick to replace x, I'll be fine. Let me clear. That's one type of problem. Let me move that to the side. I'm actually going to delete that. Let me put something else here. Again, if you don't, anyone's watching, and you want to just skip to the problems that you think matter, then you go ahead and do that. Minus 5, right? That gets rid of this. So I have absolute value of 3x plus 4 is less or equal to negative 2. So before you even start what you call solving or anything, think about what you're actually doing. You're taking the absolute value of something. So again, let me try to hide this. I want you to ignore the 3x plus 4 because that's really not important right now. I just want you to think about what it says here. It says here, taking the absolute value of something and it's going to be less than negative 2. Think about that for a second. So, and then on this side, I want you to think about, take the absolute value of something so that it's less than a negative number. If you take the absolute value of 5, that's well, it's going to be 5. Is 5 less than negative 2? No. Take the absolute value of a negative number, negative 1,000,000. The absolute value of negative 1,000,000 is 1,000,000 because that's how far it's from 0. And it's 1,000,000 less than negative 2. If you take the absolute value of anything or any number, it will always turn out to be a positive number. Why? Because we're measuring distance. So therefore, there is no way you can take the absolute value of anything and that value be less than a negative number. So for this particular problem, there's no solution because that's just not possible. You can't take the absolute value of something and that something be less than negative 2. So this problem wouldn't end up right here. Let's move on to the next one. So let's see what this provides us, kind of entertainment. So again, let me just make it a little bigger. And the first thing you should do is let's just simplify this. Minus 6 minus 6. Absolute value of x minus 6. This crosses out. Is greater or equal to negative 4, negative 6 is negative 10. So again, the first thing I want you to do is think about what you're being asked to find. So take the absolute value of something and have it be greater than negative 10. What are all the possible solutions? Can you take the absolute value of 10? Would that be greater than 10? Absolute value of 1, would that be greater than negative 10? Sorry. Absolute value of 0 is 0. Is that greater than negative 10? Absolute value of negative, I don't know, negative 899.7. That would be 899.7. And is that greater than a negative number? So you see, just by taking a second here and thinking about what this statement is saying, you might realize something special here. If you take the absolute value of anything, it's going to be a positive number because we're measuring distance away from 0, right? And because distance can't be negative, the absolute value of everything that you take is always going to be positive. So is there a way that you can take the absolute value of a number and it not be greater than 10? It's always going to be greater than negative 10. In fact, it's going to be greater than any negative value. So this one, actually, you have an infinite number of solutions because the absolute value of anything, infinite number of solutions. The absolute value of anything is going to be greater than negative 10. So that's how I leave it. Next one, see if that's even more interesting. I don't want to do this one. Well, let's do it just to find out what happens. So minus 4, and this crosses out. So I'm left with 2x minus 1 less than 4 minus 4 is 0. Again, take the absolute value of something and have the answer be less than 0. Is that even possible? Knowing what you know, that if you take the absolute value of anything, it will always be positive. Even if you took the absolute value of 0, is 0 less than 0? No. So for this one, again, you can stop. And this would be no solution. And you can write your explanation at the bottom, blah, 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 because the absolute value of anything that I take will always be positive, and a positive number is always greater than 0, therefore this will never happen. Okay, so there was a point to that problem. This one, let's see if that presents. So, let's simplify our problem. First thing I would do is plus 4. So I get 2, absolute value x minus 1, cross out, greater or equal to 6. I will divide by 2, and I get x minus 1 is greater or equal to 0. So, now we gotta think about things. So let's start thinking. What is the absolute value of something? What's the numbers that you can take the absolute value of and be greater or equal to 3? Well, hopefully you realize that if you take the absolute value of 2, it's not going to work, right? So again, don't think about x minus 1. Just think about this as the absolute value of something. When is it greater or equal to? Well, if it's 3, it works. If it's 3.1, it works. If it's less than 3, this is not going to work. So I'm going to shade my circle. And 3 works, 4, 5, 6, 7. Negative 2 doesn't work. Negative 1 doesn't work. So anything lower than 3, less than 3 is not going to work. But anything equal to 3 or higher works. So all these numbers from there on work. So negative 2 doesn't work. This doesn't work. And I'm sorry, any number in between. Sorry, that's a 2. 1, 0 doesn't work. 0.5, 0.2. Negative 1 also doesn't work. The absolute value of negative 1 is not greater than 3. Negative 2 doesn't work. Negative 3, if I took the absolute value of negative 3, it would equal to 3. And is 3 greater or equal to 3? Yes, so 3 works. 3.1 will work. 3.2, negative 4, and everything else on the left side. So this tells me that now, when I solve my inequality, which I haven't done yet, right? So now I know what this number has to be. The number inside the absolute values symbol has to be 3 or higher, or negative 3 or lower on that side, right? So you want to now set. So we're looking for, what can we replace x with? So that this becomes a number either on this side, a number either on that side, so that it's equal or greater to 3. So, 2 things you're going to do. It's 1, take the absolute value. So I know that this has to be greater or equal to 3, right? This value has to be greater or equal to 3, or this value has to be less or equal to negative 3. Yeah, but those are my 2 conditions here in order for this to be true. So if you solve it, you get plus 1, x is greater or equal to 4, plus 1, and x is less or equal to negative 2. Now, if you want to check, you can check. So this is telling me that if I pick a value for x that's 4 or greater, I will make this thing true. Well, let's pick 4. 4 minus 1 is 3, and 3 is greater or equal to 3. True. Let's pick 5. 5 minus 1 is 4. 4 is definitely greater or equal to 3. So you can see any value above or equal to 4, and I substitute here, will make it true. How about on this side? It says that if I pick a value that is -2 or less, it will work. Well, let's pick -2. -2 minus 1 is -3. Absolute value -3 is greater or equal to 3. Check. Let me pick -5. -5 and minus -1 is -6. And if I take the absolute value of -6 is 6. That is greater or equal to 3. So the values for x, numbers I can put here, okay, and I can write here. So it's going to be x has to be greater than 4 for this to work, or x has to be less than 2. Okay, so you got your two conditions, and that seems to be it. So that should hopefully help you a little bit. Oh yeah, I know what I wanted to do now. So these are some problems that we've done. I'm just gonna pick some random ones. This is by elimination. So remember what elimination is. By elimination, let me take this one. Doesn't really matter. So by elimination, I want to set one of them. An easier one? Yeah, there isn't. So by elimination, so I'm going to take the first equation, and I'm going to write it in terms of y. So I'm going to change that equation so that it looks like this. Y equals something. So I have, and I'm doing number 6 by the way, 8x plus y equals -16. So let me do minus 8x, and this crosses out. I'm going to be left with y equals, and again, I want to write the x first and then my constant second. So I can write it as minus 8x minus 16. So I know what y is. Y is equal to this unknown value. I'm going to take that information and use it in this second equation. So every time I see a y, I'm going to replace it with this fellow over here. So therefore I have, change colors, -3x plus -8x minus 16 equals -5. So I replace the y value over here with what was given to me with the first equation. So if I well, let me remove the parentheses. Because there's a plus sign in front of the parentheses, everybody who's inside comes out the same way. Their signs won't change. Combine like terms, these two can be combined, and I get -11x minus 16 equals -5 plus 16 plus 16, I'm going to get -11x equals 11. Divide by -11, divide by -11, and I get x equals -1. So I have x equals -1. I can go back to this equation right here. Okay. And I can find what y is now that I have x. So I have y equals -8x minus 16. I'm going to replace that x with -1. So I get y equals -8 times -1 minus 16. Y equals 8, and 8 is +8 minus 16. And y equals -16 because 8 minus 16. Oops. 8 minus 16 is -8. So I know my point of intersection. If it's going to be, again, right, my coordinate is going to be -1, -8. So if you were to graph these two, they would meet, they would intersect. That point of intersection on the graph would be point -1 and -8. So that's how you do it by substitution. I'm going to switch now to something else. And this is by substitution. I don't know what that was. No, this is by substitution. This should be by elimination. Oh, okay, I did it backwards. Doesn't matter. So let's do this by elimination. And now elimination, remember, that means that we're going to add these two and eliminate. So I might do 2 here just because. Let's take this one, number 8. If I were to add this right now, I get 7 plus 8 is 15x. 2y plus 2y, they're both positive, so it's just 4y. And 24 plus 30 is 54. I got nothing accomplished. I still have an equation with two variables which I cannot solve. But if I take the first one, multiply by, you know what, multiply by negative 1. If I take that and multiply every single one by negative 1, I'm going to get negative 7x minus 2y equals negative 24. Let me rewrite the second equation at the bottom, which I'm not going to change. Equals 3. Now, if I add these two right now, negative 7x plus 8x just gives me x. These two cross out, which is exactly what I wanted to do. And finally, negative 24 plus 30 is positive 6. Now that I found my x, go back to any of these equations, whichever one you want, and replace x with 6. So let's just take the first one. So 7x plus 2y equals 24. I'm going to replace an x equals 6. Let me just write that on top. So 7 times 6 plus 2y equals 24. 7 times 6 is 42, plus 2y equals 24. Minus 42, minus 42. 2y is negative 18, I think. Yeah. And y equals negative 9. So the point of intersection here would be 6 and 9. And just to make sure you understand what that means, it means that if I were to graph this equation and this equation, they would cross somewhere, and that would be 6 and 9. Oops, it should be somewhere on the other side. But I will check. What I'll do right now is I'll erase it. I found my point of intersection. Hopefully that was 6, 9. And I'm going to take that and replace it here. So I get 7 times 6 plus 2 times 9, and I know that's not right. Was it negative 9? Let me go back. Yes, it was negative 9. So 7 times 6, right, because this x is 6, plus 2 times negative 9 equals 24. Let's see if that's true. 7 times 6 is 42. Positive 2 and negative 9 is negative 18 equals 24. And 42 minus 18 is 24, which equals 24. So we worked for the first equation. Make sure it also works for the second equation. So 8x, or 8 times 6, plus 2 times negative 9 should give you 30. 8 times 6 is 48. 2 times negative 9 is negative 18, equals 30. And 48 minus 18 is 30. And 30 equals 30. So you see this point satisfied both equations. And it's the only point that will satisfy the equation because that is their point of intersection where the two lines meet. Okay, so that was by substitution or elimination. I forgot which one we were doing. Elimination. Yeah. I will do one more. And again, these are problems that you already did, but I'm just going over the procedure. So let's take this number 12. So number 12, if I were to add them right now, nothing would, nothing would get eliminated. So I'm going to multiply this first line, multiply that first line by, do I want to make this 14? Why not? So I'm going to multiply that by 2, and I'll multiply this one by, let's make negative 7. 2 times negative 7x is negative 14x. 2 times y is plus 2y. And 2 times negative 19 is negative 38. At the bottom, it's negative 7, okay? And the reason I chose negative 7 because negative 7 and negative 2x is going to give me positive 14x. And you can tell those two will be going out. Negative 7 and 3y is negative 21y. And negative 7 times negative 19 is going to be positive 133. That was not the best choice because of the big numbers, but 7 times 9 is 63. 63 goes 6, 7. Okay, so how should I have this? Now, if I add these, you notice that the x are gone. 2 positive and 21 negative is negative 19y. And 133, 33 and 38. Positives are going to win, so I have to subtract. 13 minus 8 is 5. It becomes a 12, right? 12 minus 3 is 9, so it's 95. Really? Okay. 95. Yeah, that looks right. And is anything times 9 times anything goes 95? Did I do something wrong? No. I'm just wondering if I did something wrong, because most of these problems should not have. So this is number 12. Let me just check number 12. There's an answer key here. 2 and negative 5. So I definitely did something wrong. So number 12. What did I do wrong? This is negative, and that's positive 2y. 2 times negative 19 is negative 38, so that's correct. Negative 7, that's 14x. Negative 7 plus 3y is negative 21y. Did I do the 19 times 7 wrong? So 19 is 9 por 7, 63, plus 6, 133. And that should have been positive. That's okay. These go out. This becomes 19y, because it's 2y and 21 positive, so that's 19y. Positive 19y. And 133 minus 38. How am I messing this up? So let me borrow from here. 0, 12, 13 minus 8 is 5, and 12 minus 3 is indeed 9. So I guess I gotta, no, but it's, ugh. Okay, hang on. I'm multiplying something wrong. Negative 7, negative 2x is 14x. Positive. Negative 7 plus 3y is negative 21y. Negative this and negative that is... yeah, so... select top. Negative 14x. Hey, I'm gonna pause so you don't have to like deal with this. Pause. Well, there was nothing wrong. It's the fact that I don't know how to write the number 19. I keep looking at this as 9. This should be 19. That's why. So it should be negative 19. There you go. So, nothing wrong. Divide by negative 19. Divide by negative 19. Y equals negative 5. So, y equals negative 5. Go back to either of your equations. Find the value of x. So, pick whatever you want. So, let's just pick the first one. So, negative 7x. And I'm going to substitute. I'm going to, in place of y, I'm going to put negative, so plus negative 5 equals negative 19. And instead of writing that, and I don't know why I wrote it, I can just write minus negative 5, because it's the same thing. Positive and negative and negative. So plus 5. Plus 5. That crosses out. I got negative 14 over here, negative 7x. Divide both sides by negative 7. And x equals positive 2. So there is our point 2 and negative 5. So their point of intersection on a graph would be x equals 2, y equals negative 5. So, and again, I don't want to make this video longer than it should, so go ahead, take this point, substitute it in this first equation, substitute in the second equation, and you'll see that it will make the left side equals the right side. Okay? I think that's the second one I do, so I'm done with this. Now, is it one was graphing? No, I think this one was graphing. So I'm going to take eeny, meeny, miny. Nope, this is either. So let's take this one. These are already sort of done for you, so I might show you a couple. So you want to write them in this format, which is y equals mx plus b. Mx plus b, where m is your slope, and b represents your y-intercept. Okay, so in this case, the first point, it's the interception is negative 4, so I know the line is going to cross over here. It's a positive slope, so it's going to be something that goes up. And let me put the 3 over 1, right? So that the change in y is 3 and the change in x is 1. So they're both positive. So positive on the y-axis means go 3 up. Positive on the x-axis means that the 1 here means you're going to right. So let's go 3 up. 1, 2, 3, 1 up. 1, 2, 3, and 1 to the right. 1, 2, 3, and 1 to the right. So here's my first line. Y equals 3x minus 4. And let's look at our second line. Our second line, it's negative, so I know already that this is going to be a negative slope. It's going to be coming down. It's going to cross the y-axis at 3. And your slope is negative 1 over 2. So just to go over this, now you don't see the minus sign attached to 1 or attached to 2. So you get to pick. You want to write it like this, or you want to write it like this. It doesn't matter. They all give you the same number. So if you were to put the calculator on the calculator and you did 1 divided by negative 2, or negative 1 divided by 2, or even 1 divided by 2 and then attach a negative sign to it, you would still get the same value, which is negative 0.5. So, but as far as slope goes, this tells me, and then again, currently it's right now, you need to pick either this, or either this, make the top one negative or the negative one negative, bottom one negative. It doesn't matter. So I'm going to choose that this is represented as negative 1 over 2, which means the change in x. So in x, as far as the x, okay, the y value, the movement on the y-axis is going to be down, 1 down, and the movement on the x-axis is going to be positive. So it's going to be 1 down, 2 right, 1 down, 2 right, and right away I found my point of intersection. 1 right, 2 down, and then on the other side it would be the opposite, 1 up, 2 left, 1 up, 2 left. And for me to graph it, so 1 up, 1 down, 2 right. So here's my second line. Y equals negative half x plus 3. And the point of intersection in this case is 2, 2. Do yourselves a favor and check. Meaning, take the extra time. Substitute the point 2, 2 in this equation. Put 2 over here and 2 over here. Well, they're the same. X is 2, y is 2. So you would actually get 2 equals 3 times 2 minus 4. 2 equals 3 times 2 is 6 minus 4. And 2 equals 2. First equation, check. It works. Point 2, and 2. So now second equation. Instead of y, I'm going to put 2 equals negative 1/2 of 2 plus 3. Well, 2 equals, and 1/2 of 2 is 1, but negative, so it's negative 1 plus 3, and 2 equals negative 1 plus 3, which is 2. So again, this point, 2, 2, satisfied this equation and that equation. Okay. And I want to do a different one, so I'm going to pause, one that you actually have to change. So let me pause. Pause. Okay, so I found, again, part of your homework. So let me pick 2 random ones. Let me pick 17. So 17, it's not written in the format equation of the line. So I'm going to take the first equation, x plus y, x plus 3y equals 12, equals negative 12, and I'm going to throw everyone to the other side, which is basically what I'm doing, right? So if I do this, let me take the x out, minus x on this side. This x gets canceled, and I am left with 3y. On this side, I know it says minus 12 minus x, which a lot of you might write it like this, but if I switch this, as long as I move that whole term to the front, and move the minus 12 to the back, it is equivalent. So do not write, because we want our equation to be in this format, mx plus b, right? Where this is my constant, so it should always be in the back, and my slope should be front. So minus x minus 12, right? Now I have to get rid of this 3, so I'm going to divide this guy by 3, which means I divide this guy by 3 and this guy by 3. So my equation of the line, I'm going to write it here in the corner, equals y equals negative x over 3 minus 12 over 3 is just 4 simplified. So now the only thing I'm going to add to this is that in front of the x, there's a 1 right here, right? So that the 1 is going to represent my change in y, and the 3 represents my change in x, right? So that's my slope. So the slope of this first equation is negative 1/3, and my y-intercept is negative 4. So I'm done with the first equation. Second equation, 5x minus 3y equals negative 6. 5x minus 3y equals negative 6. Again, I want to throw everything to the other side and isolate my y, so I'm going to do minus 5x first and minus 5x first. So I'm left with negative 3y, and on the other side, I'm writing the 5x first. Negative 5x minus 6. I'm going to divide everything by negative 3. That gets out, so I get left with negative y equals, and this, the negative and the negative gives me a positive, so I can actually write 5/3 x. And negative and a negative against positive, and 6 over 3 is just 2. So here's my equation of my second line, written in the form where slope mx plus 2. So it's 5/3 x plus 2. My slope is 5/3. And my intercept is 2. Okay, so basically the slope is telling you how to get from one point to the other. So let me graph this first one. It b equals 2, which means it crosses here. It goes up. Right, it's going to go up. So imagine this tells me to go up 5 and 3 to the right. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3. So it'd be here. And I know I'm out of the graph, but that's where it would be. And on the other side, I need to, if I were to graph points on the other side, I can't go 5 up and 3 down. I'd have to go opposite, right? 1, 2, 3, 4, 5 down and 3 left. Right? So, and if I wanted to continue, 1, 2, 3, 4, 5, and 3 left, it'd probably be somewhere over here. Now, connect the dots, and there is your line. So slope, literally, I guess in whatever language that is just how do I get from one point to the other? I would use that relationship, 5 over 3. Yeah, that's it. So let me just label this. This is my line 5 over 3x plus 2. A line that crosses the y-axis through 2, and that from one point to the other, the slope is 5/3. That's that. Next line, let me change colors. Next line says it goes through the y-axis and it's going to hit negative 4. So it's going to hit right here. And it's going to aim down. Now, aiming down, it's going to be a line that comes this way, so I would have to go negative 1, 1 down, 3 right, 1 down, 3 right, 1 down, 3 right. It'd be somewhere over here. If I were to continue drawing on the other side, it'd be 1 up, 3 left, just backwards. And here is our intersection. 1 up, 3 left. So you can tell, here's my second line. Y equals negative 1/3 x minus 4. M equals negative 1/3, B equals that, and my point of intersection is negative 3. Negative 3. Again, think about what that means. It means that this point right here is on this line, and that point exists on that line as well. So, and if a point exists on a line, obviously it satisfies the equation. And just to prove that, I'm going to take the first equation that says x plus 3y equals negative 12, and I'm going to use this point right here to see if it works. So in place of x and y, I substitute with negative 3, so I get negative 3 plus 3 times negative 3, and that should give me negative 12. That's negative 3. 3 times negative 3 is negative 9, equals negative 12, and you can clearly tell that negative 3 and negative 9 is negative 12, equals negative 12. Ta-da! Second one, let's issue work for the second one too. So it's 5 times -3 minus 3 times -3, and that all should give -6. 5 times -3 is -15. -3 and -3 is +9 equals -6, and this should give you -15 and +9 is -6, which equals -6 on the other side. So you see this point does exist in this line and does exist in that line. Okay. And I think now there's one more thing, finding equation of a line given 2 points. So let me find that first, and then I'll pause. Found it. So actually, I didn't even need to. So you know, I won't even use it. So here are 2 points, and I'm making these 2 points up. 0.34 and -5 and 2. So just to get an idea, let me sort of see where they are. 3, 4 would be 1, 2, 3, 4 up, somewhere over here. -5 and 2 would be 1, 2, 3, 4, 5, -5 and 2. So somewhere over here. If I were to connect these 2 points, it had a positive slope. So I can get a preview of what my equation of my line is going to look like. So I know it's going to be something with a positive slope. Now, basically, if you were to graph, I'm asking you find the slope. So what would be the distance to go up from this point to this point? So if you were to give me direction, you would tell me, hey, go up 1, 2, 3, 4, and then go right 1, 2, 3, 4, 5, 6, 7, 8, whatever it is. And that would be my slope. The change in x and then change in y. Basically, the distance, the difference between the x values and the y values. That's what we're finding. So slope, change in y, change in x. So let's find the difference between those two values. So let's pick x1, y1. Let's set that as 1 points, and this one y2. So we're subtracting, right? So we're finding the difference between 2 points. So let's subtract. So let's write this as y2, y1, x2, x1. And y2 is 2. Y1 is 4, so again -4. And x2 is -5. And minus x1, which is 3. So this looks like it's going to be -2 over -8, which you can simplify to -1/4. So the slope of this line is -1/4. So it'd be 1 up. Nope, no, sorry, positive, because it's a negative divided by negative. So +1/4. So I want 1 up, 4 right, 1 up, 4 right, 1 up, 4 right, 1 up, 4 right. So that's what this is telling you. That's the slope. So going back to my equation of my line, right? I now have, let me substitute, dm was 1/4. I need to find this guy over here, b. Well, in order to find b, I need a y value and an x value, which I do have, either this one or this one, right? Given that this has negatives, let's not deal with negatives. Let's just use 3 and 4. So in place of the y, I can put a 4. In place of the x, I can put a 3. And that gets rid of 2 of the 3 variables that I had, because I had a y and an x and a b. X got rid of. I'm substituted with a 3. The y I substituted with a 4. So now I only have one variable, which is the b, which is what I'm trying to find anyway. So 4 equals, and 1/4 times 3 is just 3/4 plus b. One-step equation, subtract 3/4 from this side, subtract 3/4 from that side, and I'm going to get that b equals 3 and 1/4. So think about 3/4 being 75, and 4 minus 0.75 is just 4.25, 3.25 or 3 and 1/4. So the slope is 3 and 1/4. So I know that this point right here, where it's crossing the y-axis, is 3 and 1/4. Now I have everything I need to write my equation. I have my y-intercept over here, and I have my slope over here. So y equals slope, which is 1/4 times x, plus 3 and 1/4, which is my y-intercept. Okay, I'll do one more. let's do a negative one. So let's pick negative 2 and let's go all the way to 7, and let's do one that goes to 5 and negative 6. So if you were just to graph this, just so that you would see, so 2 over, 7 up, that would be 1 point, 5 over and 6 down, so 1 point. So just for you to imagine how this would look, it looks like a point like that. So I know my slope is negative, and it crosses the y-axis somewhere over here. And so let's look at what the slope is, right? So if you were to go from point to point to point to point to point to point, how will you get there? Is it 1 down, 4 left, 1 down, 4 right? I mean, 2 down, 4 right. Whatever it is, that's what we're trying to find. So set your y's, and so that's x1, y1, x2, y2. You can call them whatever you want. You want to call them x3, y3, or this is just some way of you identifying who's your first and who's your second number. So slope y2, which is negative 6, minus y1, which is 7. x2, which is 5, minus x1, which is negative 2. This is negative 13 over 5 plus 2 is 7. So there's my slope. And you can tell it's negative. Perfect. Found my slope. I need to find my y-intercept. Where does this line hit the y-axis? So I'm going to use my equation, y equals mx plus b, and substitute these three values, y, m, and x, leaving me with only one variable, which is the one I want to find. So m I know, we just found, is negative 13 over 7. Y or x, I need a point on this line, and I'm given these 2 points are on this line. So you either choose this one or this one, it doesn't really matter. So I need a point in that line, and let's pick this one. Y is 7, x is negative 2, times, we're multiplying, don't forget we're multiplying, plus b. Continue over here, I get 7 equals, and negative times negative is a positive, and I get 26 over 7 plus b. 7 equals, this is, let me just change it to mixed number, 3 and 5/7 plus b. And if I subtract negative 3 5/7 on this side, then I subtract over this side, I'm going to get that b is going to be 3 and 2/7 positive. So this point right here, my y-intercept, is the point 3 and 2/7. Okay, so now I have all the information that I need to create my equation of the line. So my equation of the line says that y equals m, which is my slope here, negative 13 over 7x, plus, which is positive, 3 and 2/7, and that's my y-intercept. Okay. Wow, 58 minutes. God bless if anybody actually watches this.